So, welcome to the second tutorial, a little bit more in-deep information about the MAS framework and how to work with it. These are the 6 points we will have a look at today. We start with the simulation config. I'm going to show you some things you can configure over it. Then we check different output types. Afterwards, we will working on with the Wolfe-Sheep predation model, get rid of the grass growth agent and then introduce a new agent which we call grass and which is more powerful. And then we will have a look at different ways to create new agents. And finally, we will then integrate the precipitation layer that the grass agent can use to access weather data. Okay, so all these points are shown on the right side for you as an overview. At first, let's just start and run the program, and we see when we run it that it will run through. But sometimes when the programs are larger, it takes more time. So we want to see how fast or how our progress is. So first, let's check. You have two different ways to configure your simulation, either by the config.json or if you create it directly as a deserialized object here. And I'm going to do this, but either way are possible. So globals, we can have plenty of options here in globals. And the first thing I want to show you is that you can show console progress too. And if you activate that and you run the program, then you see the progress bar and you have an idea how fast or how long your simulation needs to finish, right? The second thing is we need for later a real dependency to real dates. So right now we just say the simulation takes 2 steps, right? But what we want is we want a real start point in time, and that's a date time. And we're gonna pass the date time, and it requires to have a format like this. First the month, then year, first the year, then month and day. Then you say T for time, and then you put the time there. So at this point, the simulation should start, and here it should end, let's say, in the 1st of April. So it's about 3 months. And now we have to say how much is, how long does a tick lasts? So what's the logical equivalent of a tick? So our delta t unit, and you see you have here different possibilities. Often we have seconds, but let's say in this case, we say days. So we will have then about 95 days, 93 days, or 90 days, which is quite good for our model. Okay, keep it running. And we see now it takes a little bit more longer, and we have 90 execution steps. Okay, and when we will want to have a look. Okay, so this was about the first point. Now we want to have a look at different output types. So as you have seen maybe already here in the config, that our output target is CSV. We have this described in the global, so it means we want to have an output target for every agent and every layer. So let's have a look when we are here in our model Wolfe-Sheep tutorial. There is our model, and if we go in the bin folder debug, then we see that here for the grassland layer, we have for every tick a CSV file. We have a CSV file for the grace growth agent, and as well as for sheep and wolf, right? Okay, and now we could open that and analyze it, but maybe we don't want to have output targets for everything, but only for the sheep. So you can also, let's go to the sheep, say only here we want to have an output target and we want to have a CSV file here. So let me delete all these CSV files so that we can check if new ones are created. Okay, all are gone. I run the program one more time. And you see a new sheep CSV is created. Okay, what we also have are different types. So we could also think about saving the stuff into a database. Let's say an SQLite, for instance, which is quite easy because there is only a file created. For databases, we need to have real temporal references. So that's a good thing that we changed that already. I run the program one more time. And you now see that we have here also the Mars SQLite file. I might want to open it with the program. I have here my data grip, and let's have a look. When I see if I have exactly that file. So let's go to the tutorial, Wolfe-Sheep Predation bin debug netcore app and the Mars SQLite. I open that up. And if I then access the sheep table, then this is the result I get. Okay, so probably I am not interested in all of that. So I want to filter the result before I print it out, because maybe at the end you will create massive amount of data, which is several gigabytes of size. So we could add also a filter here, which looks like this. You say output filter, and you have to create a new list of output filter because there might be more than just one. And I create a new output filter, and this output filter requires some parameters. So first I have to tell which is the property, so which would be here the column I want to use for filtering, let's say the tick column. And I have to tell which values I want to have to check. I need here an object array because it could be different or several. Let's say I'm only interested in tick 3. And finally, I have to say if I want to have everything where tick is 3 or everything where tick is not 3. Let's say I only want to have these with 3. I run the whole thing again. And when I refresh my data grip query, my database query, then I would now expect to have only okay, I did not have the correct console here, so I had to jump to the query console. Wait, not that one. I can create a new one, jump to query console, new console. And if I say here, give me everything from sheep, then I get only the sheep from tick 3. And if I run the whole program with more sheep, then of course there should be more Wolfe-Sheep in my result, as you can see. Okay, so this is the way you can filter the results. This next task is also finished. Let's have a look at the grass growth agent. So our grass growth agent was implemented like as an agent here. So it uses the interface of the agent. It's conceptually an agent, but in fact, this agent is just an agent which updates the grassland, and it has no other logic. And what we want to do is to have agents that act on the agent pattern. So they have an own life cycle, they sense their data, they act on it. And so this is just some kind of solution because someone or we didn't know how to put this information in the layer. So what we want is we want our grassland layer to be ticked. And to achieve that, we just let the layer implement the stepped active layer interface. And it requires us to have these three methods. Tick is pretty clear, I guess. And pre-tick and post-tick provides possibility to do something before the tick or do something after the tick. So we can act or react on things that happened in this tick. So, and all the information of the grass growth agent, we just copy it and put it here. And we don't have to reference grassland because we are in grassland. Or you could also write this, which is essentially the same. And that's it. And now the only thing which is missing is that our grass growth agent had a property which was initialized by a value from the config. Right, you remember we have here the grass growth agent and we have an individual mapping. So the same individual mapping is of course also possible for a layer. So here we have our layer, the grassland layer. We can just paste the same information here. And of course, we would also need this property in the grassland layer. I just put it at the top because it's coming from outside. The property description has to be imported here in the using directives. Okay. And now we can make here a breakpoint and run the whole model in the debug mode, and let's see if everything works fine. Also, we want to remove the grass growth agent because the logic of the grass growth agent is now part of the grassland layer. So I remove the grass growth agent, I delete the file, and now we see directly that we have missing references here. So we spawned it here, and in the program, it has to be excluded from the simulation config, as well as from the model description. Okay, let's run the whole program, and let's see if the program execution stops at our breakpoint, so that we know the grassland layer is actually ticked. So we have influence on it. Okay, here is a stop in the Wolf environment. We can go on, and you see the tick works. It is ticked, but the grass regrowth per step is not initialized. It's 0, but when you remember, it should be 1, right? Okay, so this is